The Security Weekly News is live on Tuesdays and Fridays at 12 o'clock Eastern Time most every week. I try to scan and produce a quick look at some major stories to help you keep up with what's going on in and around the industry in a short format. Myself, Jason Wood, and other guest commentators provide greater insight every week. I'm Doug White, and I hope that you will look for the Security Weekly News in all of your favorite podcast catchers and subscribe for the latest content.
Your organization is building and updating business-critical web applications faster than ever. And with so much pressure to move fast, you may find yourself making trade-offs between innovation and security. Now you can build fast without sacrificing security with Invicti, the zero-noise application security platform that helps your dev, sec, and ops teams work together to secure every website, web app, and API. With unparalleled accuracy, coverage, and automation, Invicti scales like no other AppSec solution. Invicti, AppSec with zero noise. Visit securityweekly.com/Invicti. Welcome back to Application Security Weekly. We just talked with Sandy Carielli about API security and her 3 words of trust, collaboration, integration, which is pretty much what Vanilla Ice said about stop, collaborate, and listen. So we'll have to have her back for a special AppSec karaoke segment. Hope you're ready, Sandy. I'm your host, Mike Shima. I'm here with John Kinsella, who probably can also do some covers as well, and it's just about time for the news. But first, a single announcement to follow us on Twitter, if it's still live, who knows, for live stream reminders, highlighted clips, memes, and more. You can find us at Sec Weekly. And John, it has been a while, so we've got a lot of news to cover, but I've got some good news and some bad news. Which would you like to hear first?
Which one involves a top 10 list?
Okay, I've got good news, bad news, and they're both the same.
How about a top 10 list of your good news? I'll take that.
So the good news is that there is another top 10 list now for large language models. And now, listeners, as John has spilled his coffee all over his keyboard, we're going to have to do a fundraiser. So please do listen and share our episodes so we get more sponsors. The bad news is that there is a top 10 list. And so we're going to have to do our episode 242 all over again and make you answer questions. So yes, there's a top 10 list here. LLMs. It's got prompt injections. Okay, makes sense. I do like it has an inadequate AI alignment, which is really much, are you using AI for a purpose that's going to be useful in the sense of customer support? So is your AI trained and constrained to do customer support types of responses in the sense of what is your order, handling an email address, looking that up rather than going unbounded into strange, tell me, write a haiku about the planets in the solar system, things like that. So there's AI alignment. I'm not explaining that one very good, but I do like seeing that in there. But then we just get...
Oh, no, the looks on my face is I just happened to click on it right before you were, before you started talking about it. And I'm like, okay, I get what they're going after. But... I think, this is, we have to, I don't think you mentioned, this is 0.1 release of this.
Indeed, yes, it is draft.
So inadequate AI alignment, poorly defined objectives, causing LLM to prioritize undesired or harmful behaviors, misaligned reward functions, insufficient testing. I mean, so beside my standard, this isn't unique to machine learning or AI or LLM, whatever they want to call it this week. That doesn't feel purely like a security thing to me.
There is...
Listeners, tell me I'm wrong.
No, I think, listeners, let us know, because there's an aspect here like alignment, and there's, a lot, there's not, there's an ethics, there's an important discussion here too. And there was I forgot to grab it, but there was in the show notes, but there was an eating disorder helpline that decided to fire their humans who were actually, by the way, also just trying to unionize, but important dimension of the story. But they fired them and said, we're now going to have a chat bot to help anyone who calls in about eating disorders. And then its chatbot went unbounded, was misaligned, and started giving a lot of harmful, very unhelpful responses to the humans who were calling up. So I wanted to grab that in as an example of that inadequate AI alignment. There was the already debunked the drone operator, where the drone supposedly was running on AI and then killed the operator, then killed the operator's command and control, which basically go watch War Games instead, because that's a much better story, and was also made up, but is more entertaining. But here again, we see like SSRF vulnerabilities, unauthorized code execution, improper error handling. These just don't feel like that meatiness that we want. This is a little bit why we are poking at top 10 lists recently.
Yeah.
Give us something meaty that's domain specific or domain helpful. So I don't know, much more we can stomp here.
I think this is I think there's an interesting thing to talk about for a few more minutes. So prompt injections, obviously we've already covered that a bunch of many episodes. Data leakage, I think, is an interesting one. Inadequate sandboxing. So I think that's a good one to give a good hard think about, right? If you're either using or building some sort of LLM, how do you, and this is one of the problems with a lot of corporations are starting to put policies in place of like, don't go and use a co-pilot for your code or whatever else, right? Because your code's going back out. But if you were building an LLM, how do you think about how do you sandbox the data you're getting from the data that's you're interacting with one user from another, or it could be multi-tenant. That's interesting to think about, I think. And then the last, there was something else down here.
Data poisoning?
Yeah, probably. So like some of these are useful to have a think about. But then, yeah, as you said, like unauthorized code execution. I mean, why didn't they just say buffer overflow? And actually, a lot of these ChatGPT things probably can be buffer overflow, but that's not unique to ChatGPT, right? Or LLM in general. So good points there. Hope they keep working on it, but work in progress. I mean, obviously, it's 0.1. We're not trying to talk bad about it, but
right, work in progress. And there was at the OWASP Dublin in December. There was also another AI that wasn't a top 10 list, but was AI privacy and security risks. So hopefully there will be some collaboration between these teams or something thematic that comes out of that. Want to now take us into different tangents, different directions. I pulled together a handful of just small vulns that I think were more interesting. I wanted to talk about more the philosophy behind the vulns rather than the specifically the ones themselves. There's one about a printer logic disclosure and Jetpack. Now, with the printer logic disclosure, this is a SaaS-based application written in PHP. The vulns that were looking like they were SQL injection, they looked like the basic OWASP top 10 list going all the way back to 2003, the beginning of the list. And it made me think, okay, PHP, don't want to necessarily beat it up all the time just because it's PHP the language, but the code base looks like it's only 2 or 3 years old. And so I was like, wait a second. I think clearly, if it is only that old, to have these types of basic vulns in a modern code base just seems like you're missing anything of like, let's call it shift left. You're missing some tooling, some awareness, something there. This Jetpack vulnerability, that was an example of very specifically old code base. It was an internal security audit. So kudos to the Jetpack team. I'd love to see that type of work. It looks like this vuln dated back all the way to 2012. So here's a decade-old vuln that's just been discovered. But rather than the write-up about the CVSS score or anything about that, what I would have really loved to see in this write-up or a blog post is, how did this team find this now? Was this a matter of they actually had better tooling? They were using CodeQL, SemGrep, whatever SaaS scanner that just does a little bit better? Was it just humans make mistakes? Humans have different eyeballs, and so it was a fresh pair of eyeballs that saw this? Or was there something else that is a process that could be repeated, obviously not to find a specific vuln, but in the sense of, why do we miss a vuln for 10 years? What can we do better? And that's something I would love to see a follow-up blog post from this team talk about.
Oh, that's a great point. On the printer logic one, just to get it out of the way, I was hoping to say, how do you do a top 10 list without saying your top 10 list, but there's actually 18 vulnerabilities listed here. So my joke didn't work. But
it works for me.
18 vulns, auth bypass SQLi. I mean, you're basically, let's see, cross-site scripting, session fixation. We've got OWASP here. I mean, it's if you want like a printer application cosplaying as an OWASP top 10 list, Merry Christmas. I was saying to Mike off camera before we start recording, like I interviewed at a company many, many years ago, and they were for a pen test gig, and I didn't get it. But they were asking me if I was going into an office, where would I look for my first finger holds to pop the company? And I can't remember what I said. But the answer they were looking for was start with the printer. And, that was at least 15 years ago, and we still have, and I know this isn't a printer, it's a print management system, but still, anyways, I'm going to stop talking about that because we get the idea. What really blew my mind on the Jetpack one, Mike, was the 102 versions which they have patched. Kudos for absolutely amazing support. And so for those who don't know, Jetpack is one of the core plugins which is used on pretty much any, I'll say, commercially oriented WordPress site out there, right? So they make a collection of tools to help with SEO and performance issues and caching and a bunch of really cool different things for WordPress. There's an open source version of it too, I believe. But they've gone back. I mean, stop. Anyone out there coding, not to give you the scaries, but think about if you have to apply a patch to the last 5 versions of the software you released. And these guys just did it for 102. That's some work. I mean, even if it's a simple patch, just to do the releases, even if you're just fixing a typo in a README, to do maybe that's why they're able to do it. I mean, the question then also becomes okay, if you find a vulnerability, how many of your versions are you willing to go back and patch based on how complex that fix is? So, yeah, this is that's impressive. It might be interesting to go and look at the code and see what they actually fixed. I haven't done that yet, but yeah, it's I like your point too of how do you. And this is, again, it's a blameless type thing. We're both big fans of blameless, looking back at how do we fix these things, is when you find something like this, and let's be honest, WordPress plugins, I think we've talked plenty about those. They tend to be, weak on the security side. Not saying Jetpack, but in general. But how do you go back and look for those? And then as a software vendor, once you found this one, do you look for others? Well, not do you. What other similar patterns can you look for? Either was this done by a particular developer you need to go back and look for, or was this a particular type of functionality or feature? Are you using that type of code somewhere else in your application? Can you write a semgrep rule for it? So it's the beginning of what could be a really good conversation. So I suspect and I'm hoping they're having that, but also for all the rest of us, it's not to make you go back and look at code you wrote 10 years ago, but what can you learn from it?
No, and I think you set that up great for the GitLab vuln that I pulled in because path traversal. So yes, of course, it is going to get a perfect 10 for path traversal. It's obviously going to get my attention. But one of the things that was more interesting to me there is that if you go back and look, there's actually been a handful of other path traversal issues within GitLab, and they have a very specific function that they have to address it, to fix it. And it's and of course I just closed my tab with it, but it's path traversal check. And what I wanted to do with this particular vuln was go back and see what the diff was to see how did they fix it. Did they just apply this particular created function that's designed to sanitize the git, or sorry, path, any type of path traversal. They won't have the specifics until 30 days after the announcement in their issue tracker. So we'll have to wait another week or two to take a look. But I just thought that was interesting because you're pointing out what other patterns would you look like? Would you look at other commits by the same developer, other commits for this type of security issue? Clearly, GitLab has had multiple path traversal issues, and so some linting here, some code scanning would potentially be helpful to find similar patterns and go fix them to avoid these Big Ten. So that was, I thought I wanted to highlight there. And we can move on to PyPI, which we mentioned a while ago was getting slammed with a whole bunch of malicious packages. So there's a lot of abuse on the system. They're now requiring multi-factor authentication to help protect user accounts for package managers. So these are all positive things. But let's gloss over that perhaps and talk about a different aspect of package management, packages, and encryption, and PGP and GPG. We both saw this article, but John, why don't you walk us through it?
PGP, GPG, yeah, you know me. Yeah, so the second part of this caught my attention. And it's we've I don't know, I'm stumbling. I've said it many times already this year. We've had this. We're watching these repos and try to figure out how do they improve security, not just for themselves, but for the ecosystem, theirs and everyone else's. But in this particular case, our fine blog author here, which we link to in our show notes, had a piece talking about, okay, well, PGP signatures on software releases. Well, no one's really verifying the signature. Sometimes the signatures are expired, or the key for the signature is expired. Sometimes the key was maybe a weekly generated key, not bits in the key, or there's all these type of potential issues with GPG because it's a complex beast, as it should be in a way, right? But still, secure defaults and all that. You're going to see a theme here coming up of secure by default and easy. But this one started starting it off of like, okay, is in 2023, I'm now sort of riffing on it, but in 2023, is PGP something we want to be using to secure our packages? Right. I remember when I was active in Apache Cloud Stack, again, many years ago, doing PGP key signing parties, right? So we'd have that
in person?
Trust. Yeah, in
Nice.
person. But that's, fell apart quickly because this stuff is both hard to keep going and also people aren't really interested in PGP key parties for some reason. There weren't very many people in that room. But yeah, is this it, or do we turn to something newer, or how do we, if we're going to do, we've been talking about code signing on here, but okay, well, what does that actually mean, or how are you signing, or how are you verifying, and all those type of things start coming back, and it's not just the signing part we need to make easy, it's the overall process.
Yeah, and it goes back to the very classic, why Johnny can't encrypt, why Johnny still can't encrypt. So, PGP has had people have been complaining about its UX since the 90s. So, we've now sandwiched war games, PyPI, and now we've hit some 90s here as well. But I think the only thing I would add there too is, even for example, Golang is like, we don't want to support PGP or GPG in our crypto libraries anymore. So we're going to keep that there, but if you want to use it, you're on your own. So I think the industry itself is also moving away just from GPG in general, which I don't think anybody will truly complain about. Nobody's going to miss them too much. But John, speaking of other things that we possibly will miss because it was actually a good contribution to passwords, for that matter, bcrypt. You have this. Tell us about bye bcrypt.
Yeah, so I thought this is it's a refreshing article in Wired, and apologies, probably paywall, but Wired's probably one of the better things out there you can pay for, if I can throw that bone. But the article started talking. It's I believe it's based off a blog post which the author of bcrypt put out, Niels Provos. Bcrypt's been around for 25 years. As an AppSec person, I'm sure Mike's the same way, as we go in and we're consulting with either our own teams or someone else's teams about how do you do encryption properly. One of the words which more frequently comes out of our mouth over the last, probably not 25 years, but many years, is use bcrypt, right? A, don't roll your own. B, use something which exists. How about bcrypt? But the interesting thing about both security and crypto in particular is what is the best or the best choice today isn't always going to be the best choice. So, right, as computers get faster, and we'll, get my rainbow hands and talk about quantum compute. But the truth of it is, at some point in time, either through quantum or just standard old CPUs, at some point they're going to be fast enough to break something which we consider secure today. So what this article is about is thinking about, let's start sunsetting bcrypt, maybe not initially, but like, hey, let's start realizing that it's not going to be perfect forever, and there's going to be something coming up next. And I don't want someone, well, from the author's point of view, I don't want someone using the software forever. So I think it was really refreshing and really great to hear someone sort of get ahead of that curve, no pun intended, and think about what's next out there. So, and not just for, the takeaway again for this is not just, hey, this encryption guy is doing this, but this comes to all of us for both our normal software, but particularly our security stuff. So I thought that was a pretty good read.
It is cool. And, I'll throw in another pitch for also consider moving to WebAuthn. So let's get rid of passwords and get into passkeys more as well. And there's some cryptography here to tie into. We're just talking about PyPI and the PGP. There's been certificate chains and certificate transparency. SigStore and transparency chains for these types of signatures might be the better developer experience, the better user experience to say, should I trust this signature or not? Or has it been modified or who signed this? So I think those are probably pointing to constructive aspects, examples of what the future looks like. I think those might be a good direction. There were two other things related to passwords here, KeePass, and then we get to another fun one. But talk us about this master password, John.
Yes. I'm going to go back because I just thought a really good joke on, or actually not even a joke, an analogy on the signing thing. Mm-hmm. For those of you outside the U.S., you're probably not going to understand this, but in America, we still have to sign our credit card receipts in many cases. And most of us, when we pay for something with a credit card and we sign, we're just scribbling, right? Like my wife does this very careful signature, which she can repeat every time, but most of it's just sort of scribble on a page. And that's sort of the way I think some people are signing their packages, which they release. They're just like, how do we find a signature and slap that bad boy on there and send it on away because we want to get back to code. And it's like the Visa scribble. Anyways, master keys. Yes. So the snark I left in our show notes is one of these password safes out there is secure. We just need to find it and someone needs to tell us who it is. So a lot of folks use KeePass on the open source side where they don't want to trust one of the cloud providers that are always having security vulnerabilities. So they went over to KeePass, which has a Mac version called KeePass X. But these fine fellows found a way to get the master. So the way this works, the way most of these things work, right, just to sort of talk it through, is there is a master password which you have to type in to get access to your password safe. And that master password is used to unencrypted things, see everything inside. And what they found here, this vuln came out a little bit ago, but if KeePass is running, the plain text of that master password is in memory. And that's not really a great thing. It requires to get access to the box and jump through all the normal hoops to get it, but it was found and it's now patched. So go update your KeePasses, those of you who are using it. But, just yet another thing out there for us to keep track of. Nothing really detailed about it.
No, and I'll come back to this, but I'll mention too. It also kind of points out that one the competitions, the frictions between writing code into the compiler, doing things like zeroing out memory. Often developers will think, I would need to zero this memory. Compilers will say, it's going to be more performant. We don't need to zero this memory. Let's just skip over it. No one's going to look at it again. But if it's leaking, as you're typing your password, obviously that is a reason that you would have wanted that chosen as a good password. If you do need a good password, John, I did provide in the show notes a way to generate a secure password from the lyrics of America's greatest singer-songwriter. That is Kenny Loggins, which I think really I love the PUD. I love the retro aspect of it.
Yeah.
Go listen to the Top Gun soundtrack. It's wonderful. But I also wanted to, joking aside, having fun aside, I still actually want to have fun. This is kind of a great step towards just like security awareness, security education. And this would be a fun way of just talking about passwords or WebAuthn or not having passwords for that matter. And honestly, I'd probably diminish a little bit worry about password complexity because that only matters if you actually comprise the original hashes, but more focus on 2FA, the ecosystem around passwords. So there is a little bit of education in here, but Kenny Loggins, wonderful pun, chef's kiss for this one.
Oh my God, in the past. Yeah, so we open our news tabs before we hop on and start recording, and I also nearly spilt my coffee out of this one. The passwords are pretty cool. They're actually, they're relatively Kenny's Loggins-ish. But then, so me with my browser security, I use a module which doesn't enable JavaScript by default, so I had to go and enable that so this would work. And I have to give kudos for I don't know if you saw it, Mike, the service behind, which is actually doing the generation. So this is looks like it is some sort of SaaS, which is, it's not all being generated in the browser, which for passwords is good, right? Because you need to have that somewhere else. But the domain which he's calling back to are they I don't know who the person is SDASDBJASDBKAKDB.online. So credit for the random fingering when you're generating that domain name there. That's really cute. I don't think that's from a service. I'm guessing they registered that. But anyways, yeah, we got our giggles.
Yes, we got our giggles, and shout out to Steve, Candace, Craig, and Jordan. It sounds like a team of 4 people putting that together. So thank you very much. I do have some other fun, some fun education though in that vein. There is from Wizard Zines, and this is Julia Evans' work, and we've covered a few of her zines in the past. This is Memory Spy, which is a way to look at variables as they're represented in memory by C programs. Now, I'm going to say up front, you don't necessarily need to know C programs. It's a great way to just click on some of the examples, and you could just to see what does this look like as you have an integer, whether it's a 32-bit integer or signed versus unsigned. So it's a really neat way to visually, if you're a visual learner, to see how is this represented. So it can be just a fun intro to just some basic concepts of endianness, signed versus unsigned, integer overflows, things like that. So I thought it was really neat and a good way just to kill some time without having to actually do any coding yourself.
I broke it. Now it makes me wonder if there's a vulnerability in it. Because if I go to run if I have nothing, my browser the JavaScript thing was gone, so there was nothing in the code box on the left, and I clicked run, and I got a LD error, undefined reference to main. Which makes me think this is being run, which makes me go.
It is being it is being executed in a very small resource constrained container. I think the execution time is limited to 1 second. So an empty. It may have that might be a compiler error that you're seeing in there.
Yeah. But still, that could be something for our users who are like, we're always talking about how do you find, not always, but we frequently talk about how do you find something like this test. So there's, I'm going to tell our listeners to go and use this in a way which was not intended. I hope they do not mind, but poke at that a little bit and sort of go, okay, what does it look like? Because that thought process I had, that was live. I hadn't looked at this before, but that's how we go through this. It's like we see something, we get a response we don't expect, and then we go, oh, hey, what else can I do with that? So there's at least my homework to my listeners. Go, pretties, go and have fun.
Go have fun, do some coordinated disclosure, be constructive there. I think there was also another project, implement DNS in a weekend. And here I thought I'd reference that too. Not that we need yet another bind or to rewrite bind from C or C++ into Rust or Go over a weekend. That's not the point. The point is more to learn a protocol. And so this is more of pick a protocol. DNS is an easy one you could play around with, but there are HTTP2, HTTP3. There are other bit more complex protocols as well. But this is a really fun way to learn Python in this case, or learn Rust, learn Go. Pick a protocol and look see if it's easy to understand what the RFC describes. See what areas are ambiguous. See as you're making implementation mistakes, that's other mistakes that people are likely making as well. So this is sort of that security-minded, how are RFCs turned into services? Having some insights on that, having some exercise and playing with that is a great way just to build up some pen testing, some attacker-minded thinking. So I don't know if what language you might try to build DNS in a weekend, John, or if there's anything else here.
I wouldn't. I've run DNS professionally before. I know how difficult that is. It is massively difficult. I would not even consider. Yeah. Sorry to our server huggers who like running DNS at home. You're making a fatal mistake. But I think with that said, right, it seems like so simple. It's like, oh, how hard can it be? UDP on port 53, get a query and respond to it. It's so simple. Oh yeah, go ahead and give it a try, guys. It's massively complex.
Massively complex, but a great hobby, great way to learn. So, find something practical. And for those people running servers out there, John, I think you need to warn them that they might crash after a few days. What's going on here?
This was fun. My idea of fun. So, I don't know, we seem to, and I just get this off the Google News, but I seem to be talking a lot about AMD's EPYC chipset. This is the AMD EPYC Rome was found to crash after 1,444 days. 1,044 days online. We consider that bad. Most of us don't have servers running that long. That's considered frowned upon nowadays, even though I've got one that shutting down pretty soon, I think is well over that. But the point here is, okay, so, haha, funny, someone can't count. I'm going to pause for a few seconds and let our listeners think about what might be causing this. Why would you actually have a server crash after, something like this? And the story comes down to, well, let's see, the one of the core clocks is running at 2.8 gigahertz. 2.8 gigahertz times 10 to the sixths times 1042.5 days, which is the actual number of days. It crashes in 1042 days and 12 hours. But that comes down to a hex number of 0x38 followed by many zeros, which is basically you're getting an integer overflow. So it goes bang. And it's, it's, I was having a discussion with someone last week about at what point does in this case a startup, at what point does a company, and hi if you're listening, at what point does a startup start unit testing their software, and what do you unit test? And I was trying to get them to start unit testing some stuff that, well, it might not be broken now. You're going to want that automated testing in place in the future to catch things when they do break, that particular algorithm, but also to show your potential customers that, hey, we're going to do what we can to try and make this stuff right. And I'm bringing that back here from a point of view of like, I'm sure these things are tested upside down, inside out, but still, do you unit test? And we've talked before about how do you do time-based unit testing for either figuring out something that's, running for too long or too short. And this is yet another example of the professionals that, we all make mistakes. So funny to see it. This probably, it's not like something short, so we know how to work around this, right? Reboot the machine, don't let it go that long. You're probably going to patch before then anyways, but also test.
And yes, I think we live in a world where long uptimes are not anything to brag about, especially if that means you haven't been applying security patches that require reboots, et cetera, or even just updating normal patches. Speaking of patching and looking at things in the cloud in particular, John, you've been looking at AWS was getting your attention for better and worse, I suppose?
More than likely. Let's see. We've got a few stories here. I want to see which one you're riffing off of. Oh, yeah. I got two of them. Well, one in particular. But I was... so one of these articles has been going around all the newsletters for the last few weeks, and they're both good articles, but I'll start with the first one from a company called BiteWax. And to sort of lead into this, what BiteWax does is their day-to-day business is allowing a user or a company to use Python for your stream processing coming off of Kafka or something like that. And they wrote a blog post saying, hey, how do we detect anomalies in our AWS infrastructures? And then parenthesized, and have peaceful nights. I'm not too sure about the peaceful nights part, but hey, cool. But beside... I think it's really great to start to read through how do you do, we talk about machine learning or anomaly detection or all these type of things, and this area is it's not like LLM, right? Anomaly detection's been around for ages, particularly the concept, but also the math behind it. How do you do this type of stuff? So this is sort of walking through how did they set up for their prod infrastructure. Getting the data that they need off Amazon, and then getting it to the right place where they can use their software, which they write, and then using their software that they write to see if there's anomalies in basically logs coming off their systems. My friends, it's not a short blog post. And that's sort of my point here is it looks like they're running Kubernetes. So, set up a namespace, cert manager, blah, blah, Red Panda cluster, because they need that also for some of the gathering the data and doing stuff on it. Exporting CloudWatch, so they have to get stuff out of, they have to get stuff out of CloudWatch and then get over to the Cube cluster, and then and I'm still going Logstash, Kubernetes, and then we need to finally we're going to get to the data flow to detect this with BiteWax. So some Python code. Still going, and you got to test it, which I think they cover a little bit. And then, we need a Docker image to be able to run that in, and then something about Kafka, and finally a conclusion. Okay, cool. Great example. Something to do on a weekend and get some experience around. Because there's books out there on anomaly detection for security folks. I think O'Reilly has one, if I remember right. But it's the part about this, and maybe I'll talk about it a separate week. But I'm trying to recently. Last 6-10 months, I've been trying to gather data or figure out a good source for data to really play with some of these things at home. If I'm not working in a corporation, which I'm not right now, how do I get a bunch of data, like live data, to be able to do this type of testing without building it myself? But even once you have it, running this and learning how to do this is great. But my point both on this and on the next article, which is Pinterest talking about how they're doing real-time anomaly detection, they're both long posts. And you know, I understand not everything should be nice and neat and packaged because that's what people charge for. But at the same time, this stuff has been around for a while. But on the case of the second one, they're not talking so much about how they got this stuff up and running to do this. It's just, if you're doing this, how do we tune it to make it useful? And there's a really great concept towards the beginning of it, I believe, where they talk about, real-time detection, not so much of what you're trying, the anomaly, but in the drift of your ML model. Because depending on how you train or when you train it, do you train it once? Do you train it continually? Do you have a feedback loop in there? All these things, as you get closer and closer to reality of actually using this stuff in prod and not getting woken up at 3 o'clock in the morning, it's not easy. And my point here is, beside looking at this and you know, when I go, this is what I want to see if I go to someone having, by the way, out there, people doing talks. If I go to a talk that's talking about how you're using machine learning in production, I want to see this type of stuff, like how you're actually doing feedback and learning and making it better, not just like standing it up and we had a nice day, because that's not real. But and I'll shut up here in a second. But I think this is really useful for folks to think about, okay, how do we get this in there? How do we get it going? How do we improve? And how do we make it useful? And that's not something you can just pick up off the shelf. So if your coworker or a manager or a vendor says, hey, just use machine learning, or it's so simple, or you can do it in a weekend, no, that's almost guaranteed to not be the case, unfortunately.
No. And we talked with Sandy about, we mentioned like vulnerabilities, and getting more visibility into flaws doesn't mean that you just have suddenly a great new volume of fix all the vulns. I think there's a correlation here where you're saying, you know, increased visibility, just throwing more data into an ML model to create more signals is going to burn out that SOC analyst, or it's going to wake you up in the middle of the night when you didn't need to. So it's that quality of training is what you're hitting. We're going to have to wrap up quick, so I do want to mention there was the newest ThinkstScapes Quarterly. They went through 700 presentations, 1,500 blog posts, pulled out a couple interesting things to them. They do have one about compromising real-world LLM integrated applications with prompt injection. So that was might be a fun one to look at. They mentioned server-side prototype pollution, which we actually talked about in the news segment, John, back in ASW 230. 3 others I'll highlight real quick. High-risk users and where to find them. It's just a great aspect of the people aspect of security. Another one, why I write my own security tooling, which talks about the benefits of writing security tooling to learn for personal education, but more as well as a documentation experience, so that others can, yourself and others can learn from research you were doing in the past, perhaps a very small focused area of code. And then finally, real quick, finding 10x performance improvements in C++ with CodeQL, which set aside the C++ aspect, but it's more of, it's nice to see a CodeQL, a tool that is often used for security, have developer value as well, in the sense of where are patterns that are working against performance, things like that. So it's nice to see, I'll call them dual use tools in the sense of security and performance, but that's kind of the theme I wanted to hit there. So don't know if you had a chance to read through the research yet, if there's a couple that you'd like to highlight or something else that you'd like to leave for a departing message for our users.
Yes, like those stories, we hope this podcast is dual use and that it is both educational and informative. And I want to leave with 2 things. How will I say? They are different but important. So there's 2 sort of pledges going on out there right now in the community, which you may or may not have heard of. One is called Stop Silly Security Awards. You know, Adrian Snobria on Enterprise Security Weekly, he's really in depth on this type of thing, but there's a lot of pay-to-play security wars out there. So this is basically get your vendors, or you, if you are a vendor, sign on and stop giving those people money for stupid trophies. We all know they're fake. And then there's a second one, ethics and security. So that same sort of thing of like let's we're trying to do the right thing. All of us here, most of us in the world, we're trying to get the stuff done correctly, but a lot of people are selling snake oil. So let's try and not so much expose those, but take the positive track and do the right thing ourselves and pledge that.
No, I think that's an excellent message, John. Thank you. Thanks to everyone else as well for joining us. Let us know which of the articles you're enjoying, how we're presenting them. We'd love to hear more feedback from you as well, especially if there are other tools that we should be highlighting.
Especially positive feedback.
Especially positive feedback. Indeed. So, and especially please subscribe, hit that like button, check out the show notes. And speaking of anomalies, check out Anomaly by Starfarer. We'll see you next time on Application Security Weekly.